Lovely, thank you.
Please.
Does this thing work? Yep, it does. Okay. Hi, everyone. I know it's a slightly provocative title. Bear with. My name's Callum. I work at Diamond in the data acquisition group, but perhaps more relevant to this is the fact that about 5 years ago, I very nearly did a PhD in type theory, and now I write Python for a living. And I do sometimes look at myself in the mirror and ask exactly what happened. I'm not entirely sure, but part of the answer is this. My facility, like many others, is transitioning to Blue Sky, which is written entirely in Python. We've heard a lot about this already. What we've heard slightly less about is the system we are transitioning from, GDA, which is a large Java monolith from the late 90s. This is obviously a big change, and it opens up a lot of doors for us because, I mean, collaboration-wise, obviously, we get to work with people from other facilities, but actually, my group specifically gets to work with other groups in Diamond better, because guess what? They all write Python too. So for many, many reasons, the technology change makes sense, and obviously that's not what this is about, but there is one big flaw. We have 25 Java developers, and we've walked up to them and gone, hello, you are now Python developers, congratulations. They're not all happy about that. I mentioned that early on because I want to be very clear that this is not just a nerdy talk about programming. It is a nerdy talk about programming languages, but also it's not, because there are real consequences to this, right? I will be blunt. We have lost people over this decision. People have resigned because that is not what they want for their career. We have also gained people who we probably wouldn't have gained because, you know, the technology you work with is an important part of your career plans. So we were aware from early on, as we did this, that we needed to find a way to bridge this gap for our Java developers. We want to keep them around. We want to keep them happy. And there are a few different ways you can do that. One of them is to make sure that you're actually writing modern Python, which sounds simple, but lots of us don't do it. We are talking about, you know, all the various modern language features that make it easier, generators, coroutines, and yes, type annotations, which form part of a lot of people's workflows. This slide is really just to make the point that, yeah, we are talking about the thing where you put :int after your variable. This is becoming fairly widely adopted by industry. It's driven by industry. So this is a graph showing how popular Python has got over the last 20 years. It started as something fairly obscure. Note, this is a log scale. It started as something fairly obscure and has now grown into one of the most popular programming languages in the world. So yeah, industry has driven it to be more robust and better able to cope with large numbers of lines of code in a code base. As a brief aside, because everyone who's seen this has asked me why Rust and TypeScript took a massive dip at the end of the pandemic, and I have no idea. If anyone does know, please tell me. So that's the story of industry. In the research community, I think it's more mixed. And I'll be honest, I don't know entirely. This is partly why I'm doing this talk. I'm interested in where people are at with this. But at Diamond, especially in my team, we've consolidated a project template for Python applications, which kind of amalgamates our favorite tools. So people are familiar with, you know, Rough, hopefully. We've locked ourselves quite firmly into GitHub because, you know, that's a fairly safe bet these days, dev containers, etc. And Pyrite, which is Microsoft's type checker. We migrated to that from MyPy, but I'll get more into that in a moment. We like the tool. We find it very useful, but it is very opinionated. It does not give you many options to configure. I don't know if people use Cookie, which is the Scientific Python's standard template, which has many, many configuration options depending on what type of project you want, what your favorite tools are. We have very much gone down the direction of these are our favorite tools. These are your favorite tools. If you have other favorite tools, you need a really good reason to use them. And we realized quite early on that we're being quite strict and that our favorite tools are quite strict compared to both other people at Diamond and other facilities. Despite that, this is actually a talk about how we're going to try and be a bit stricter, and that may be scary. So I kind of wanted to walk through what we've done and hopefully make it look less scary. Before I do that, the other important thing to mention is flexibility. Most people who know Python, who learned Python, they value it for its flexibility and its shallow learning curve, right? It's very easy to write. It's very easy to learn. You don't need to type very much. If we're adding this complexity by making you type another thing, adding cognitive load, that seems to scare people. Another thing is, what if I know I'm right, the type system disagrees with me, and I can't get anywhere without it? So the important caveat to all this is that Python's type system is opt-out, right? Here we have two very similar pieces of code. One's Python, one's Java. They both have the same mistake. There is a null check that should be here and isn't. The error message in both cases is almost exactly the same. The difference is, in Python, I can put a type ignore directive up there, and then the type checker will let me do it anyway. But I'm basically telling it, yeah, I know I'm right, because if type checking is optional, the type checker can definitely be wrong. Meanwhile, in Java, if the type checker disagrees with you, you're not running your code. And I just think that's an important point to mention, because Java hasn't gone extinct. So clearly, it is possible to survive this. One other thing while we're on this topic, because I don't want anyone thinking that we force beamline scientists to do this either. The important thing is that the core code, so things like Blue Sky and our Python APIs, our REST APIs, our services, and so forth, are robust. User experimental code, which runs on top of those, doesn't have to be robust, but the thing it runs on should be bomb-proof, and that is kind of what we're driving towards here. So that's kind of some preamble. The meat of this talk is that we started with MyPy, which is a fairly buggy type checker. It's developed by the community. It has about 1,000 issues going at any one time. If you do something very obviously wrong, it will shout at you, but it has many things it will miss. So we've started to migrate our repositories to Pyrite, which was written by Microsoft and has therefore had a lot more money poured into it. And more recently, I've turned on Pyrite's strict mode for a couple of Diamonds repositories, mostly just to see what would happen. What happened was the number of type errors multiplied by about 10, because strict mode is about as strict as something like Java or TypeScript, kind of roughly in that domain, which means it will actually tell me off if I don't do things pretty much perfectly. And I'm going to go through some examples in a moment, which hopefully highlight how this works. So the exemplar repository for this is one called ScanSpec, which I converted to strict mode in a PR link there. And all of these examples are from that, and I'll get into why that is in a moment. But the first thing is, for function signatures, you have to put type annotations, right? So that immediately generated a whole bunch of error messages. It shouted at me going, no, can't have that, can't have that. I don't know what bounds is. It's obvious what bounds is, right? It's a Boolean, but still, the type checker demanded that I tell it it's a Boolean. The reason for that is it helps to make the code self-documenting. What we now have is a function that takes two Booleans and returns a list of frames of axes. That may not mean much, but it means more than a function that takes two things and may or may not return anything. If you're a Vim enthusiast, this won't mean much to you, but if you're an IDE, I can now hover over that function with my mouse and it will tell me that, and that's also incredibly helpful. I also have to supply generics, so this is important. Any kind of generic, so we have there a tuple of types. Types of what? In non-strict mode, it defaults to any. In strict mode, it defaults to unknown, and those are very different things because Pyrite will not allow me to have an unknown variable, which means I need to tell it any at the very least. Ideally, I should tell it something narrower, and we'll get to that, but I have to tell it. Usually, I do try to narrow it. So in this case, I had a type there. It's easier, actually, if I pretend for a moment, if I fill in the defaults that Pyrite regular mode has, right? I have a type of any. I've turned it into a type of C. I have a callable that takes anything and returns an any. I've turned it into a callable that takes a C and returns a T. And then the whole function returns a T. So now those types have to match up. This is another good example. I have a generic there, which converts to another generic. That actually doesn't work. The type does not narrow. I have to return a union. Again, that's not caught without strict mode. But what it means is, anytime I use the object returned by this function, I have to handle both cases, T or U. And that's extremely useful because maybe my code handles the T case 90% of the time and the U case 10% of the time, which means I won't catch this problem until the 10th time this is run in production. So there's two main reasons why you want typing, and they're both related. The short answer is you don't want to deploy incorrect code. That sounds obvious, but we do it all the time, right? Usually because of time pressure and deadlines, etc., we do not always have time to make our code correct. But there are two reasons why we really should. Number one is our code could break, and then our facility doesn't work, and that's very bad. And if we have fixes, it may take a long Hello? Yep. Hello. Oh, it's out of batteries, I see. We don't have time to test it in production. We may have to wait a long time to test things. So any errors that can be caught, excuse me, can be caught early while during development, that's extremely worthwhile, and that is what a type checker will do for you. The other reason why correctness is important is because this is software that collects data, which means any incorrectness is a source of error in your data, ultimately. The scientific validity of what we do is improved by having a model that tells us whether our assumptions are correct or not. This is just another example of that. We've become very focused on lots and lots of CI pipelines and rigor so that we can deploy with confidence. And we're finding that projects we do this with are the ones that get reported from the floor less. So obviously this is not perfect, right? There are some drawbacks. The learning curve is definitely one of them. Yeah, it's more to learn. But that said, all of these examples I took completely out of context, right? I originally had some very simple examples with foos and bars and so forth, and I ended up taking some real examples instead because actually I think adding this information makes it easier to read. And while you don't get the context from this, you maybe get a better idea of what the function is doing, right? You probably don't know what a spec is or a zip is, but you know that a spec of U converts to a zip of T to U, and that is different to a spec of U converting to a zip of U. You already get some idea from that. So there is some self-documentation that comes out of this. The big drawback, though, is that it's optional, which means that a bunch of libraries don't provide enough typing information, and that makes Pyrite very unhappy. You have to type ignore stuff there. You have to cast. I should emphasize a cast does nothing at runtime. It's just asserting to the type checker that, yes, I know you don't have enough information to figure out what this is, but I do, and I know it's this. If you want to actually do a runtime check, you do something like an isInstance check. So because this is the obvious question, why are you using Python then? If you want to make it strict and basically work like one of these languages that comes with all this stuff out the box, why? Because Blue Sky's written in it, because Beamline scientists can speak it, and because we have a lot of legacy in it. It is our shared language. But also, as I say, we have 25 Java developers who we need to bridge the gap for. This is absolutely a compromise, but I hope it's a useful one. And I also hope that this story is useful to someone who's migrating their stack and has a load of legacy to deal with, and also a load of legacy people to deal with. And I'll skip that slide for time. Here's some useful links. Any questions?
Time for maybe. I have to grab this one. Yeah. Sorry.
What else? Yeah, thanks for the introduction of this type checker. You said you took example from real life out of context.
Yeah.
And I wonder, none of your function had any doc strings. I prefer reading doc strings. I'm not an IDE. I'm a human being, and I write code for a human being who will read my code. So your presentation is opinionated, my comment as well.
I will say, I know, right? I was not expecting to get out of here without argument. I'll confess to something. I took the doc strings out of these examples because mostly to fit them on a slide, but also because it forces you to read the code, which is not what you would do in production, right? But in this case, the point that I'm making is all you can know about this function, especially imagine you can't even see the body of it, right? It takes this, it returns this. That already tells you something about it that you wouldn't have had before. Yeah, I agree, doc strings are great, but I don't have to put that the parameter is an integer in a doc string. And lots of people don't. You could. You could have doc string validators for that, yeah. I mean, that's also a perfectly legitimate way of doing it. But there is a bit more that you get out of type checking, which is it will validate your whole code base as a model. If I pass the wrong thing, the classic example is a function that can take either a scalar or an array, a function that takes an array, but you may think it can take a scalar as well, and you pass a scalar and you don't realize till you try to run it. That's particularly common with NumPy, right? Because most things NumPy does can deal with either scalars or arrays, but a few can't, and those are the cases that catch you. You need that back.
Yeah, I think that in interest of time, we have to. It sounds like a very good discussion, actually, and that's, I think, what Callum wanted to provoke somehow. So let's thank him again.